Alright, everyone, we'll move with module 4, that is convolutional neural network. Sorry, the pronunciation. What is convolutional? So, see, it is a what to say, convolution neural network. You can have a good what to say definition over here. It is a specialized neural network for processing data itself, but with grid type of topology. So, however you process the data, like there are different methods, but convolution is something which is grid like topology. You know what is grid like? Like that nets and all grids. So you have multiple grids. Okay, it's just like that. Okay, so basically it runs on what grid type of data? 1D grid and 2D grid. Time series audio samples over time. This is 1D. 2D is nothing but images, pixels in a row and column. See, 1D is like, like audio files and all. Like this just one direction and all. 2D is like images. It can be papers and all, etc. Pixels in rows and columns. See, it's just like that. Okay, so it includes time series data as 1D and images data as a 2D grid of pixels. They employ a mathematical operation called convolution instead of general matrix multiplication. So why are we using CNN instead of general matrix multiplication, which is used by normal nets? In CNN, we replace that with convolutional, at least in one layer. Convolutional idea using spaceship example. So suppose you have a spaceship and you just got a information about its location, but we don't know now, it might be moving or something. So we need smoothed version, that is latest, with the help of a weight average. So what is actually this W of A is nothing but a weight based on age of measurement. So age in the sense, the time, the how fresh was the information. For example, I got to know the location of the spaceship half an hour ago, so the age is half an hour. Okay, and then I got to know 5 minutes ago the H5. So which will I consider the 5 minutes ago allocation, right? Because half an hour ago, who knows where it might have gone again like that. Okay, so that's the WFA. So the smoothed output is S of t. This is the spaceship XT spaceship. Okay. So now the smoothed output S of t is equals to integral over. See, this is the actual spaceship position at previous position, but his smoothed time at smoothed output. Okay, so it's just like that. So now what you have to understand, integration of, you don't write over a in the sense, at the end dA will come. So x, so it's basically like this, x of a, then w of t minus a into dA. Okay, the integral constant you have, same thing, you just have to mention dA over here. So integration, so see, oh, let me just erase it. um Erase it in our pic. Erase, draw. See, it's just like that. Meaning in simple, to compute S of t, you need to look at many nearby time points A, multiply each xa by a weight, depends on how far it is from t, add them up, you get a cleaner value. This operation is called convolutional, written as S of t is equals to x into w into t. Okay, it's just as it is. You can just write xw of t. It is not multiplication of t. It's just like x of t or x of a, right? It's just xw of t. Okay. CNN terminology directly from, okay, this from your text you have to ignore this because this is from the textbook which I extracted and gave to the AI, which I spoke about this AI over here, which helped me process the text and generate the notes which we are studying from. So x is equals to input, w equals to kernel filter, s is equals to feature map output. Okay, so kernel is basically the pattern detector. Okay, so what pattern detector is nothing but based on the input, based on the weight, where it is going, how the spaceship pattern, where it is moving, judging its location, next location. It's just a word like that. So input, w is a kernel filter, or you can, which is nothing but weights over here. Discrete convolution, what we actually do in computers. In real computers, we don't measure every instant, we measure at intervals, like once per second. So you don't have to, every second, tuck, 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 every millisecond take the record, and it's not like that. We will wait for some interval for 5 seconds, 5 second interval. What happened? 5 seconds reading. Then we take 5 seconds. It's just like that. So time becomes integer. T is equals to, numbers minus negative and positive integers. The convolution becomes a sum. S of t is equals to sum over a, that is nothing but a is equals to minus infinity to infinity x of a into wt minus a, same thing which we had over here. See, instead of integration now we are putting summation, so weighted average, but now the sums not integral. So now we are taking the sum. Convolutional with images, 2D convolution. So here it was about 1D, okay, time series and all. Now we have to talk about images and all. For an image input I and kernel k. So input is I and kernel is k. I see I and k. Okay, I don't know. I'm not sure it is I or k. I think it is L. Okay, it's not I actually. It's L and k. Okay, so S of I comma j. Oh, okay. So S of I comma j is equals to sum over, see, summation of m summation of n I into m comma n. Then sorry, I of m comma n. Sorry, this is L of m comma n into k of I minus m and j minus n. It's very simple, right? See, S of I j, here you just put I. Sorry, what you do, you have to write L of m comma n. I know it's let us just erase that because it's not very neat. So mn is there. What you have to do, very simple to remember, write L. What the hell, bro? Yeah, good language. L. Okay, I don't know why the it happens like that. Okay, then in the bracket you have to write m comma n multiplied by k I j minus m comma minus n. So it's very simple to remember. And then what you have to do, see, in space of L, if you write k, and in place of k if you write L, what it becomes, kernel flipping versus no flipping. This is flipping the kernel. So now the meaning of this equation, put the kernel on top of small region of the image. See, I minus m. So it is some particular location, summation, some particular location. So we are putting kernel, then multiply kernel values with those pixel values, sum that becomes one output pixel of S. Okay, so basically if some image, some pixels are there, we are trying to subtract m and n, finding a location, we're placing the kernel over there. So image I m comma n. So see, that is the image into the kernel position, it gives some output. So that is our new S output. So okay, kernel flipping versus no flipping. The convolution flips the kernel. Convolution is mathematically computing because of kernel flipping, but most ML libraries don't flip. They implement cross correlation. So simply what is happening. So what was multiplied with k is now being multiplied with L, and what was multiplied with I is now being multiplied with k. So here libraries often call this convolution anyway. It doesn't matter much because during training the network will learn the correct kernel orientation. In deep learning, convolution usually means cross correlation, no flip, but we still call it convolution. So flipping or no flipping, both are considered as convolutional. If they ask you about what is convolution, you might have to talk about what it is actually, the equation, how we took I, how we take input, how we take kernel, and how we take that weight W of A, and what is A over here as age, age of the, what is that name, age of what, Ultron. No, bro. W of A is nothing, age of measurement, and then how smoother output is written in integration, then how it is converted into summation. So actual convolution operation is written over here. Okay, xt of sorry, xw of t. Terminology, see, xws, the summation of minus infinity to infinity when it is about 1d. When it is up to 2d, we have to talk about summation of m and n. Then after 1d and 2d, you have to talk about kernel flipping and no flipping. Then say that it is actually not convolution, but still it is considered as convolution. That's it. Then we have to talk about motivation. So we'll be talking about what motivated this convolution, how it actually works, and like diagrams and all are involved. We'll see that in the next video. But before we move to the next video, you can actually also see here that like different way of answers, like how it generates smart nodes. Alternative nodes is also says the same, convolution nothing but weighted average divided by weighted sum over nearby values. So specific example, they have to talk about that. Input kernel map feature, see S, say XWS, same thing. Discrete convolution, what you really implement. 2D inversion, this is 1D, 2D, then convolution versus cross correlation. This is kernel versus no flip versus flip. That's it. And then convolution as matrix multiplication. Actually here you have to talk about two matrix multiplication, that is Toeplitz and block circle length. It's which is actually mentioned in the detailed notes of my this subject, but I don't prefer it because equations have not been actually taken extracted properly. But you can see here you have Toeplitz multiplication, two dimensional case. You can just study this and prepare for the exam.